Hello friends, Mr. Burrell here. We have just finished Unit 3 when we were talking about a lot of things associated with polynomial functions. We talked about adding, subtracting, and multiplying polynomial functions. We talked about complex numbers. We talked about identifying how many solutions a polynomial function has, real and imaginary solutions. And we talked about a lot of different characteristics of polynomial function graphs and how we can use them and where they're applicable, like end behavior, and where a function is increasing or decreasing, minimum points, maximum points. Talked about all those kinds of things in relation to polynomial functions. Now we're going to extend that a little bit further and further talk about polynomial functions, a lot more about solving polynomial functions. We've talked about how to identify the kinds of solutions and how many solutions a polynomial function has. Now we're going to focus more on being able to solve a variety of polynomial functions. To start, we're going to talk about and review factoring and solving quadratic functions. We talked about solving quadratic functions in Math 2, and it's really critical, it's really important, and it's really helpful in what we're going to be talking about in this unit. So we're going to review it and teach it again to get us an idea of how to factor and solve quadratic equations. So just a side note about quadratic expressions. Why do we learn about it? We've talked about kind of the applications of polynomial functions in the world. Specifically, here are some examples of where polynomial functions are applicable when they are in quadratic form, these quadratic expressions. So finding the area of a room, determining a profit for a business, athletics, anything where you throw a ball, throw a javelin, punt a football, whenever you're throwing something in the air and it's coming back down again, that can be modeled with a quadratic expression. Launch and landing of a rocket, throwing something off a cliff, all those kinds of situations can be modeled using quadratic functions, quadratic expressions. So that's why we're going to talk about it, and we'll see some examples of that throughout this unit. So here are your objectives for this unit. I want you to be able to put a quadratic equation in standard form. I want you to be able to find the greatest common factor of an equation, identify a, b, and c in a quadratic equation, and find two numbers that multiply to ac and add to b. Hopefully those steps right there, those first four, are relatively familiar to you, because then beyond that, our next objectives are factoring a quadratic equation and finding the solutions of a quadratic once it is in factored form. We'll extend that a little bit. All of that will be a little bit of review, a lot of new, and then we'll talk about using a factoring shortcut and factoring quadratic equations using a difference of squares, and we'll talk about what that means here in a bit. So some additional standards, some additional objectives, some of the things we want you to get you out of this, of this lesson, besides just the math, is to be able to make sense of problems and persevere in solving them, look for and make use of structure, and look for and express regularity in repeated reasoning. That's taken straight from the core standards for Math 3. So hopefully in what we're doing in this lesson, you start to notice some patterns, and you start to notice some things that keep happening in some situations that constantly occur with factoring quadratic functions. Hopefully you can make it seem like kind of a puzzle that has a certain way to solve it every single time. So some definitions before we start talking about quadratic functions. A zero, we've talked a lot about this. When we're talking about polynomial functions, a zero is a value of x which makes the function f of x equal to 0, or where y is equal to 0. We often talk about zeros as solutions, x-intercepts, roots, the answers, but that's what we're talking about. We've talked about how we need to find the zeros or the solutions to polynomial functions. We're going to do the same thing now, except narrowing it down to quadratic functions. A factor, as a noun, a factor is a number, a variable, or an expression that divides the product exactly. So, for example, if I have like the number 12, a factor of 12 would be 2 or 3 or 4 or 6, because all of those numbers divide this number exactly. 2 goes perfectly into 12, 3 goes perfectly into 12, 4 goes perfectly into 12, etc., etc., etc. 5 would not be a factor of 12 because it does not divide perfectly into it. So we'll extend that beyond just our real numbers here, but that's what a factor is. A factor in the verb sense, when we are factoring, when I say that this unit is on factoring quadratics, we're rewriting a polynomial as a multiplication expression instead of solely as an addition expression. And I'll show you an example of what that looks like here in a second. A greatest common factor is the greatest number and or variable that is a factor, here's this factor, that is a factor of 2 or more terms. So for example, if I had 12 and 18, the greatest common factor I would be trying to find is the greatest number that is a factor of both of these terms. And we'll talk about how to find that here in the next couple of slides. So those are some definitions as far as factoring and solving quadratic expressions. So, to solve quadratic equations algebraically, we need the equation to be in factored form. We can change a quadratic equation into standard form to factored form by factoring or undistributing the equation as shown in this example. So here is an example of a function, a quadratic function that's in standard form. This is an addition expression. I have 3 different terms all being added together, x squared plus 13x plus 42. An example of the factored version of that equation, of that function, would be x plus 7 times x plus 6. I have written it as 2 factors, 2 sets of parentheses that are multiplied together. So, to show you that this is actually indeed the same expression, I'm going to go ahead and multiply these together. So x plus 7 times x plus 6, let's multiply those together and make sure that this is actually the same as this expression, x squared plus 13x plus 42. So I need to multiply everything in the first parentheses by everything in the second parentheses, which gives me x times x, which is x squared, x times 6, which is positive 6x, 7 times x, which is a positive 7x, and 7 times 6, which is a positive 42. When I combine my like terms, here in the middle is 6x plus 7x, I get x squared plus 13x plus 42. So notice here, these right here are the exact same equation, just one is in standard form, one is in factored form. Pay attention to these steps here. Pay attention to the structure that I find here. X plus 7 times x plus 6. When I multiply 7 and 6 together, I got 42. And when I added 7 and 6 together, I got 13x here. Pay attention to that structure. Well, I'll go ahead and do this one real quick too, so you can see what we're doing. In Unit 3, when we were talking about polynomial functions, this is a problem that I would have given you. Multiply these polynomials together. 2x times x is 2x squared. 2x times 4 is a positive 8x. Negative 3 times x is negative 3x. 3 times 4, negative 3 times 4 is negative 12. When I combine like terms, I get 2x squared plus 5x minus 12. So what we're talking about now in this lesson, in this upcoming unit, is we're going from this form, this standard form, back to factored form. Because in factored form, when we have a function in this form, it's a lot easier to solve or to find the zeros. Because you notice if I set this equal to 0, we've talked about this, if I have these 2 factors being multiplied together that are set equal to 0, I can set each of them equal to 0 and find my solutions that way. So when a quadratic is in factored form, it's so much easier to solve rather than when it's in this form, because looking at this function, it's really hard to be able to know what those solutions are. But in factored form, it's a lot more clear. Just a reminder that a standard form of a quadratic looks like this: ax squared plus bx plus c, where a, b, and c are all just numbers, real numbers, usually whole numbers like 4, 5, negative 7, 8, integers like that. Okay, so with all that kind of as a base, before we go delve fully into factoring quadratics, we're going to talk about taking out a greatest common factor. So greatest common factor, again, we defined this on the previous page, is the largest common divisor. So it's the largest number that is common, divisor, that is common between 2 terms. A term that is the largest that will divide into 2 terms. So because it has to be into 2 or more terms, right here it says there must be 2 or more terms in order to have a greatest common factor. Next it says factoring out the greatest common factor means to divide each term by what they all share. So let me show you an example. I have 3x cubed minus 12x squared, and I want to factor out a greatest common factor, or in other words, I want to find the term that is the largest term that could divide into both of these individual terms. So what I'm going to do is I'm going to split each of these terms into their prime factors. So 3x cubed, that's equal to 3 times x times x times x. 12x squared, well, that's equal to, when I break down 12, if I do a little factor tree, 12 is equal to 4 times 3, and 4 is equal to 2 times 2. So broken down into its prime factors, 12 is 3 times 2 times 2, and then x squared here is broken down into x times x. So the things that are in common between those two terms are 3 and then 2 x's. So I have a greatest common factor of 3 and 2 x's, or 3x squared. So then in each of these terms, what's left after I take out this greatest common factor? Well, in my 3x cubed term, the only thing that's left is x, so I'm going to write an x here. And in my 12x squared term, the only thing that's left is 2 times 2, which is 4. And this negative here. So I'm left with x minus 4. So when I'm factoring two terms like this, my first step is to take out a greatest common factor, in this case, which was 3x squared. In this example right here, I have 3 terms. I'm going to write them down here. I have negative 18x squared, I have negative 30x, and I have negative 24. So if I break down negative 18, let me just break down 18 real quick. 18 is 9 times 2. 9 is 3 times 3. And then I have this negative. So I'm going to write negative 18x squared as negative 1 times 3 times 3 times 2. And then x squared is x times x. Negative 30, if I'm breaking down negative 30, I get 10 and 3. Let's just break down the 30 first. And 5 and 2. And then it's negative, so I'm going to write a negative 1 out in here. Negative 1 times 5 times 3 times 2. And then times x, because of this x. Negative 24, if I break down 24, I can do 12 times 2, 4 times 3, 2 times 2. So I have negative 1 times 3 times 2 times 2 times 2. 3 times 2 times 2 times 2. So now what's in common between all of these terms? Well, there's a negative 1. There's a 3 that's in common between all of them. And there's a 2 that's in common between all of them. When I multiply all those together, negative 1 times 3 times 2 is negative 6. And I have left 3 times x, which is 3x squared. And then I have 5 times x, which is positive 5x. And then I have 2 times 2, which is a positive 4. So when I talk about taking out a greatest common factor, that's what I'm talking about. I'm talking about taking the largest multiple of a given set of terms. So in this case, I had 2 terms. I took the largest number and variables that could be multiplied into that term. Again, if you go back to the terms that we defined for greatest common factor, the greatest number and or variable that is a factor of 2 or more terms. These, 3x squared and 6, were the greatest combination of numbers and variables that could go into all of those given terms. Okay, so now that we have factoring a greatest common factor under our belt, reminder, when we are asked to factor a quadratic, when you get those instructions, factor a quadratic, we are trying to break it down into its unsimplified form. So to change it from this form, boom, x squared minus 5x plus 6, to this term, x minus 2 times x minus 3. So we're trying to go from this form to this form. We've done a lot in the past going from this form to this form. Now we're going from this form to this form, which is why we call it factoring. So I'm going to go through the steps that we follow, the process, the patterns that we can use to set this up, to do these factoring problems. This is going to be the process you'll follow to factor every kind of quadratic you might see. If you have a quadratic expression, our first go-to is let's see if we can factor it in order to solve it. So let's use this quadratic as an example. 7x plus 2x squared plus 6. Okay, Step 1, and these are all in your guided notes. Step 1 is to write the quadratic in standard form. So here I had 7x plus 2x squared plus 6. If I write that in standard form, I write it with the exponents going from biggest to smallest. So 2x squared plus 7x plus 6. Next step is I'm going to factor out the greatest common factor if there is one. So if there's a greatest common factor, I'm going to take it out. In this case, we can you could do the factor trees and write these all out as their prime factors just to double check to see that there's nothing in common. But indeed, there is no greatest common factor between all three of these terms. So we can kind of skip this step. Step 3 says multiply a and c together and find two numbers that multiply to get ac and add to b. Hopefully some of this is a little bit familiar, ringing a little bit of a bell. So remember, our quadratic equation in standard form looks like this: ax squared plus bx plus c. So in the one that we're given, a is equal to 2, b is equal to 7, and c is equal to 6. So I need to multiply a and c together, so my first coefficient and my last coefficient, and then find two numbers that multiply to get that number and add up to b. So for example, a and c here in my equation are 2 and 6. So I multiply 2 and 6 together and I get 12. So I'm trying to find two numbers that add up to 12, or sorry, multiply to make 12 and add up to 7, or add up to b in this case. So what I've done is I've listed out all the multiples of 12. So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, and then negative 1 times negative 12 is 12, negative 2 times negative 6 is 12, negative 3 times negative 4 is 12, because a negative times a negative is a positive. So now I'm trying to find the pair of factors, the pair of these multiples here, that add up to 7. And you notice that the only ones that do that are 3 and 4. So those are the two golden numbers. These are the numbers that I'm going to be using. These are the ones that I'm concerned with. So the next step is to write the two factors in this form. And this is critical. This is really helpful. So you write the two factors in this form: x plus blank over a, x plus blank over a. And these are your two golden numbers. So I'd put 3 here, 4 here, and then underneath each of those fractions, I write a, which in our case, in this problem, is 2. So my factors end up being x plus 3 over 2, x plus 4 over 2. So these blanks in this factored form, I fill in with the two golden numbers we found up here in step 3. So I've written the quadratic in standard form. There wasn't a greatest common factor. I've multiplied a and c together and found two numbers that multiply to ac and add to b. Those numbers were 3 and 4. And then I wrote the factors in this form: x plus 3 over 2, x plus 4 over 2. Okay, next step, step 5, is reduce any fractions that I can to simplest form. So I had x plus 3 over 2, and I had x plus 4 over 2. Well, 4 divided by 2, that's a fraction that can be simplified. This one can be simplified. 4 divided by 2 is 2. So since that fraction can be simplified, I'm going to write it as x plus 3 over 2 times x plus 2. And then step 6 is if a remains in the denominator or in the bottom of any of the fractions in either factor. So here a did stay in the bottom of this fraction, then bottoms up. I'm going to transition from this form to this form. So this a, this number in the denominator, is going to shift and go up in front of the x. It's going to be multiplied by the x. So this 2, I'm going to take out of the denominator and multiply by x, giving me 2x plus 3. And then in this one, there is no number in the denominator, so I just leave that factor as is. 2x plus 3 times x plus 2. Then my very last step is if I remove the greatest common factor towards the beginning of my steps in step 2, then I can't forget to put it back in front here. Since I didn't take out a greatest common factor, I'm done. This is my factored expression. 2x plus 3 times x plus 2. Now to double check, let me make sure when I multiply these together that I actually do get this when I multiply them together. So when I multiply these, I get 2x times x and 2x times 2, 3 times x and 3 times 2. So that gives me 2x squared plus 4x plus 3x plus 6. Look, there are my golden numbers, 4 and 3. Coincidence? No, not a coincidence. So when I combine these x's together, I get 2x squared plus 7x plus 6. And I know that I did it right because I got back the original equation that I started with when I multiply my factors together. Okay, let's go on and do another example. This one, the steps aren't, I still have the steps here, but we're going to walk through each step together. So I have this function 2x squared plus 6x minus 20. So my first step is to write the quadratic in standard form, which I've done. This is already in standard form. The next step is factor out the greatest common factor. So let's see if there's a greatest common factor. 2x squared is 2 times x times x. 6x is 3 times 2 times x. 20, let's see, 20 is 5 times 4. Then 4 is 2 times 2. So negative 20 is negative 1 times 5 times 2 times 2. So the only thing in common between all of these is 2. So there is a greatest common factor, namely 2. And what's left in here, I have x squared on the inside of these parentheses, 3 times x, so positive 3x on the inside of these parentheses, and negative 1 times 5 times 2, which is negative 10. So I've taken out a greatest common factor. Now I'm going to ignore the greatest common factor for a little bit, and I'm going to deal with this simplified quadratic expression. So my next step is multiply a and c together and find two numbers that multiply to get ac and add to get b. So a quadratic is in this form. Standard form is ax squared plus bx plus c. So a in my quadratic function is 1, because there's nothing in front of the x here, it's just 1. B is equal to 3, because it's in front of the x here. And c is equal to negative 10. So I'm going to multiply a and c together. A times c is equal to 1 times negative 10, which is equal to negative 10. So I'm trying to find two numbers that multiply to make negative 10 and add to get 3. So I'm trying to find two numbers that multiply to make negative 10 and add up to 3. Okay, so let's list all my numbers that multiply to make negative 10. Well, I have negative 1 times 10. I have negative 2 times 5. And then I have 1 times negative 10 and 2 times negative 5. Okay, well, which of those pairs of numbers adds up to 3? Well, negative 1 plus 10 is 9. 1 minus 10, or 1 plus negative 10, is negative 9. Negative 2 plus 5 is 3, and 2 plus negative 5 is negative 3. So alas, since negative 2 and 5 added together make 3, those are my golden numbers. Those are the numbers that are going to come real in handy throughout the rest of this factoring process. So step 4 says write the two factors in the following form, filling in the blanks with the two numbers you found in step 3. So I have this form, x plus blank over a, which in our case was just 1, and x plus blank over a, which is just 1. And my two golden numbers are negative 2 and 5. So x plus negative 2 over 1, x plus 5 over 1. Okay, so 5 says reduce any fractions to simplest form. So I had x plus 2 over 1 and x plus negative 2 over 1 and x plus 5 over 1 as my factors. If I write those simplified, anything divided by 1 is just itself. So I can write x plus negative 2 as x minus 2. I can write x plus 5 over 1 as x plus 5. So there's nothing, I reduced those fractions. I didn't have to write 1 in the denominator, so I just wrote them as x minus 2 times x plus 5. My next step says, step 6, if a remains in the denominator or in the bottom of any of those fractions, then I have to say bottoms up. Well, I don't have any denominators left, so I don't even have to follow this step. I can kind of skip it. And I have x minus 2 times x plus 5. My very last step is if I removed my greatest common factor in step 2, I can't forget to put it back in front. And you probably noticed we did take out a greatest common factor in step 2. We took out a greatest common factor of 2. So I better write that back in front. 2 times x minus 2 times x plus 5. And you'll notice that when I multiply all these back together, 2 times x minus 2 times x plus 5, I will get 2x squared plus 6x minus 20 as my final answer in the end. So again, that's the process for factoring a quadratic function. This comes in handy when we're talking about factoring. It comes in handy in the next video when we're going to talk about solving quadratic functions. When a function is in factored form, it becomes tremendously easier to be able to find the solutions to that quadratic function. So we're going to skip over a couple of these for now. So hopefully, we're not completely done with this lesson. This lesson is going to be in 2 parts. But hopefully you feel pretty comfortable with this process, putting a quadratic equation in standard form, finding the greatest common factor, identifying a, b, and c, and finding 2 numbers that multiply to make ac and add up to b. Hopefully we're getting there on factoring a quadratic equation, and then we're going to, in the next video, talk about finding the solutions of a quadratic and using some factoring shortcuts and talking about difference of squares. We'll talk about what that means. So in the next video, we'll practice some more factoring problems and go on into the solving and some of the shortcuts. So remember also that these are the additional standards that I hoped for you to be able to start gaining throughout this lesson. Make sense of problems and persevere in solving them. Look for and make use of structure and patterns and puzzles. Look for and express regularity and repeated reasoning. So things that continue to happen and things that you continue to notice, recognizing why that's the case. Hopefully those are some things that you're able to understand. So that's the end of this video. Again, this unit 4.1 is going to be split into 2 separate lessons. So the next video will be after this one. But I hope that was helpful. Please reach out to me and let me know if you have any questions whatsoever. And I hope that you enjoyed that as much as I did.